Welcome back to chapter 12, where we are going to get into what you call, or what you think you call, geometry. So we're going to keep going with shapes, and we are going to explore solids today. So going quickly through our vocabulary, just to kind of refresh some terms you may already know. We are going to work with polyhedrons today, and those are known as solids bounded by polygons, and that's a key word there, that enclose a single region of space. In other words, we are working with 3D objects now. And polyhedrons are made up of three things, one being a face, and you can notice or label the face by it just being the polygon that you see. The edge will be a line segment formed by the intersection of two faces, and we'll talk about those and identify those in just a second. And then last, the vertex, which is the point where three or more edges meet. So over here to the left, I have already given you a cube, which you may know that shape already. It is labeled by the face. So the face is the square that you can see right there. And they have pointed that to you. The edge will be a line segment where our faces meet. So if you look at the top segment or the top polygon and the right polygon, it is the edge would be that top orange. And then the vertex is just where the three or more of those vertex or those edges meet. So if you look at this other polyhedron, we know that this could be labeled as its face. The edge would be where my polygons meet, and then the vertex again is just that point where those line segments meet. So keeping on going, we're going to label the base, and it's used to name the polyhedron. Or to classify it. And we know that the bases are congruent. So if you look to the right over here, I have a pentagonal prism, and because it is named pentagonal, or because it has pentagon bases, that is why I can label it as a pentagonal prism, because it has bases that are congruent and that are pentagons. So regular polyhedrons are polyhedrons whose faces are all congruent regular polygons. So I've kind of given you a picture of those on to the left, where you can see on the first one all of the faces of the polyhedron are triangles. Or the next one, a cube, all of the faces of this polyhedron are squares. And again, and so on and so on. So that is how you can identify regular polyhedrons. Convex polyhedrons, you can classify those as any 2 points on its surface can be connected by a line segment that lies entirely inside or on the polyhedron. And we'll look more closely at those throughout the lesson, but just make sure you get that definition down. Continuing on to Platonic solids, one of 5 regular polyhedrons. So they given the names, and I'll give you how many faces it has. So a tetrahedron, a regular tetrahedron, has 4 faces. A cube, we can say, has 6 faces. Octagonal or octahedron has 8. A regular dodecahedron has 12. And an isohedron has 20. And again, we will look more at those, and you will get better at labeling these figures. Once you see them, it'll just take a lot of practice. If you have trouble doing that, you can always go into your book, and they have a lot of pictures that you can use to kind of identify, or of course we always know we have our phones available to go and look those things up as well. If you notice over here, notice that the names of 4 of the Platonic solids end in hedron. Hedron is Greek for side or face. Sometimes a cube is called a regular hexahedron. So again, hedron means side and face, so that's where we get our name from. And last vocab word is a cross section, and we are going to actually do some more with that come tomorrow. But it's the intersection of a plane and a solid. So if you look over here, I have intersected two shapes that or solids that we are going to work with more later, but that's just kind of how you can recognize that cross section. All right, again, I want to go back and visit what is a polyhedron, and it's a solid bounded by polygons that enclose a single region of space, and we know it is made up of a face, edge, and vertex. So, using that information, we're going to go to our types of solids, and this is a good key. A polyhedron is given right there. These are the different types of polyhedrons. A prism, which you can see the faces are congruent, and a pyramid. Those are the two different types of solids that we'll look at. And then you can recognize not that they aren't polyhedrons by those three things. Again, we know that a circle is not a polygon. So the only polyhedrons we're going to look at is ones with polygons. Right, moving on to example 1, we want to tell whether the solid is a polyhedron. If it is, name the polyhedron and find the number of faces, vertices, and edges. And this might take a little bit of practice, but again, practice makes perfect, so we will keep practicing. So the first one, we will say yes, it is a polyhedron, because we don't have really any curves on it. The second one is also a polyhedron. What about the third one? Well, I see this curved place on my shape or my solid, so we are going to say no. So let's now label. So this is a polyhedron, like we said. It has 1, 2, on the back side 3, and 4 faces. So it is a tetrahedron. And it has 4 vertices, so 1, 2, 3, and 4. And it has 6 edges, so 1, 2, 3, 4, 5, and last one is 6. So I won't go as slow on the other ones, but if you need to slow it down and count yourself, you may. So we labeled that this is a polyhedron. The two bases are congruent, and we know beforehand those are labeled by its bases, and we can see it's a hexagon. So it is a hexagonal prism. It has 8 faces, 12 vertices, and 18 edges. And I would go ahead and count those just to make sure you understand where to label the vertices, the faces, and the edges. And like we said on C, no, it is not a polyhedron because the solid has a curved surface. Moving on to theorem 12.1 is Euler's theorem. So the number of faces, F, vertices, V, and edges, E, of a polyhedron are related by this formula. So our faces plus our vertices are equal to the number of edges plus 2. So that will be a consistent thing. And I have written on the side over here, if we want to find the number of edges and we know the value of faces and vertices, just subtract 2 from those two added together and you'll get your number of edges. So we're going to use that down here. So using Euler's theorem, find the number of faces, vertices, and edges of the polygon shown. Check your answer using our theorem. So we can say this has how many faces? Let's see, 1, 2, 3, 4, 5, 6, And then the back face is 7, and the front is 8. I found 8 faces, 12 vertices. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I like to look at it. If there's like a corner right there, I label that as a vertice. And I would have 18 edges if you count. So remember, an edge is 1, 2, 3, 4, and I have 18 of those. So let's check Euler's theorem. So the number of faces is 8, plus the number of vertices is 12, which makes 20. Does that equal 18 edges plus 2? It absolutely does. Right, if you want to go over here, this is kind of a fun one. Find the number of edges on a wedge of cheese. So the number of edges, so we can say E equals, how many faces do we have? Well, 1 on the back side is 2, 3 on the bottom is 4, and 5. So I have 5 faces plus the vertices, 1, 2, 3, 4, 5, and 6. Minus 2, I think I counted them all. So 11 minus 2 gives me, my edges would be 9. Alrighty. And last, we're going to describe our cross sections. As you can see, the plane has been intersected by the solid. So looking at A, what does the cross section, so the shape that is created when I cut that solid, would be a circle. I'm just labeling the shape that the cross section and solid make. Looking at B, right in here, I have that dark shaded. If you notice, that is a pentagon. What do you notice about the base? So that might tell you something. And then the last, the cross section of the cylinder done horizontally would be a rectangle. Alright, and I have a couple more questions. What if the cross section was vertical? What would that be? And I would say it would be a circle. And then looking at it, what if I cut it diagonally? What would that be? And we haven't really gone over this term, but it's called an ellipse. So it's kind of like a slanted circle. So almost like a parallelogram is to a rectangle, we're going to say an ellipse is to a square or a circle. So alrighty, and let's go through these really fast. Number 1, I would say it is a polyhedron. It has 7 faces, 10 vertices, and 15 edges. And since the bases are congruent, I can call this a pentagonal prism. Number 2, well, that looks like a circle, so can it be a polyhedron? No, it's not. And 3, yes, there's no circular or curved areas. Its base is a rectangle. So it is a rectangular prism. 5 faces, 5 vertices, and 8 edges. Alrighty, let's go quickly through here. You can do 3. Check Euler's theorem that we worked on, and I will give you the answers to 5 would be a rectangle. 6 is a pentagon. And looking at 7, oh, that looks like a triangle. Again, you can stop the checkpoints if you want to earlier, but hope you learned something today that maybe you didn't already know, and we will see you next time. Thanks.